So we are starting our electricity unit, and in order to start it, we will relate it to chemistry. All matter is made up of submicroscopic particles called atoms. At the center of each atom is a nucleus with two kinds of particles, the positively charged proton and the uncharged neutron. Protons do not move from the nucleus when an atom becomes charged. A cloud of negatively charged particles called electrons surround the nucleus. An electron has the same amount of charge as a proton, but the kind of charge is opposite. When atoms become charged, only the electrons move from atom to atom. This is because they are not contained in the nucleus. A premise behind electricity is that like charges repel each other and unlike charges attract each other. In some elements, such as copper, the nucleus has a weaker attraction for the electrons than in others, and the electrons are able to move freely from atom to atom. This makes it a conductor. In other elements, such as sulfur, the electrons are strongly bound to each atom. This makes it an insulator. In each atom, the number of electrons surrounding the nucleus equals the number of protons surrounding the nucleus. A single atom is always electrically neutral. If an atom gains an extra electron, the net charge on the atom is negative. And it is called a negative ion or a cation. If an atom loses an electron, the net charge on the atom is positive, and it is called a positive ion or a cation. So we will use these principles in order to understand electricity in this next section when we talk about exploring static charges. So in chapter 10, we are looking at, oops, that was my calculator, exploring static charges. So electricity is a form of energy that results from the interaction of charged particles, such as electrons and protons. And static electricity or static charge is an electric charge that tends to stay on the surface of an object rather than flowing away quickly. So we see static charge, for example, when you rub a balloon on your hair. And this happens on materials that are insulators, such as your hair. Static charges build up when different materials rub together, such as in a clothes dryer. When an object becomes charged by friction, one material has a stronger charge or a stronger attraction to electrons, which are negatively charged, and the other material, and therefore pulls electrons off the material that has a weaker attraction to them. So we will look at three methods of charging objects. The first method is charging by friction. And this is a process by which objects made from different materials rub against each other, producing a net static electric charge on each. An insulator is a material in which electrons cannot move easily from atom to atom. So for example, dry air, wool, glass, and rubber. We say dry airs instead of humid air. Right now in this time of year, in the fall, the air is extremely dry, which allows electrons to travel easily, which is why there's more static electricity. Another material that would be an insulator would be distilled water. If you remember from chemistry, this is water. Oops, distilled, I spelled that very wrong. Distilled water, this is water with no ions. And a conductor is a material in which electrons can move easily between atoms. So for example, any metal, for example, aluminum, copper would be a conductor, and tap water has ions present. So we talked about this, which meant that, remember, tap water was homogeneous solution, whereas distilled water was a compound when we did classification in chemistry. A superconductor is a material in which electrons can move fairly well. Semi, meaning fairly well. So germanium or silicon, and these are used in electrical applications. Another term that's important to know is a ground, and this is an object that can supply a very large number of electrons to or can remove a very large number of electrons from a charged object, therefore neutralizing the object. So these are some terms that help us understand the concepts of charging by friction. I will show you next a diagram of what grounding looks like. So in this diagram, we see that electrons flow from the earth. This is a ground, and it's showing we have a positive object, and in order to become neutral, it needs to have an equal amount of negative charges. So it would get those charges from the earth. How would that happen? Usually when you touch the object, grounding would happen. So the flow of negative charges from the earth is the same as the flow of positive charges from the object down. Now, if it's a negatively charged object, then the excess charges or electrons would be pushed into the earth in order for the object to become neutral. You have to have an equal number of positive and negative charges in order to be neutral. An object must. So how do we determine with charging by friction, how do we determine where the electrons will go? Well, we have a list of materials called the electrostatic series. And this is a list of materials that have been arranged according to their ability to hold on to electrons. So the materials at the top have a weak hold on electrons, so they would lose electrons. And at the bottom, they would gain electrons because they have a strong hold. Now, if you look at the items on the list, maybe some of this would make sense to you. So for example, objects like human hair or glass would lose electrons, wool, fur, if it was rubbed with something below. Things like rubber, a balloon, polyester, foam, grocery bags, or ebonite. Ebonite is a very hard form of rubber. So you know that the ebonite, and we have some samples of that, would always gain electrons. And so if you think about if you've ever rubbed your hair with a rubber balloon, what happens is your hair loses an electron to the balloon. So the hair would become positive and then charged, and which is why it would repel itself and your hair sticks up. All your hairs are positively charged. And then the balloon gets a charge, which is why you can then stick it to a wall, because the wall is neutral and it attracts it. But we'll see that example in a little bit. So let's take a look at this electrostatic series and see how we use it. So if we were to rub cotton and foam, we have to find them on the list and find it. Cotton is blank on the series, so it will blank electrons to foam since foam is blank on the series. So let's find cotton and foam. So cotton is here and foam is here. So cotton is higher up, so it will in fact lose electrons to foam. So it is higher on the electrostatic series. So it will lose electrons to foam since foam is lower on the series. So then foam would become, the foam would become positive. Sorry, no, the foam would become negative because it's lower on the series. Negative. And the cotton would become positive. They become oppositely charged. So whatever's higher would lose electrons and become positive. Whatever's lower is going to gain electrons and become negative. So what about fur and ebonite? So I'm going to color these in a different color. Fur and ebonite. I mentioned already, ebonite's at the bottom of the list, so it's always going to take electrons. So ebonite will gain electrons. And let me just see what you guys have to copy here. Okay. So fur will lose electrons. You'll be copying that down, and become positively charged because it is higher on the list. Ebonite will gain electrons and become negatively charged because it's lower on the list and has a strong hold on electrons. Okay? So I will indicate this again on the LMS, but the questions I'd like you to do are page 406, number 1 to 4, and page 407. I didn't want you to do page 4, yeah, and 2 to 8 actually is what I'd like you to do, 2 to 8. One last point is that the closer together the two substances are, the smaller amount of charge is transferred, and farther apart will be a greater amount of charge transferred. So I'll just write that down. Close together, small amount of charge transferred. Farther apart, greater amount of charge transferred. Okay, so as well as these 2 pages, I'd like you to do the predicting charges worksheet. If you, I'll show you what that looks like in a second. Worksheet. So it's in your package, and it looks like this. It's the next page, predicting charges. Hopefully you can see that. There we go. Okay, there's 2 pages with that. Okay, so that's the end of this lesson, and next we will look at charging by contact and induction.